So, in this question here, we're looking at question 4 of the AS Stats extension questions on integral. So hopefully you've got the question in front of you. I'll read it out to you. Claire travels to and from college by bus on the 5 days of the week that she attends college. She believes that the probability of having to wait more than 6 minutes to catch a bus is 0.4. So, and it is independent of the time of day and direction of travel, which is a bit controversial because clearly I think that's wrong. But anyway, she says it's independent of the time of day. Assume that she's correct. Well, she's not correct, is she? The amount of variability is going to be huge. But anyway, assume she's wrong. Find a probability that during a particular week, the number of times she has to wait more than 6 minutes. So we have to decide what sort of distribution this is. Well, clearly, assuming it's a binomial. So let's first of all say, let x be the number of times she has to wait. So x can represent the waiting more than 6 minutes. It's good to have all this written up like that. So x represents that. And so therefore we have a distribution of x. We know it's binomial. And we know that she's over, is it 2 weeks? Of a particular week. Oh no, it's a particular week. She has to go both ways, different directions. So it's 10 because she goes to college and back from college. And the probability is 0.4. So that's our setup, and then the question says find a probability that she has to wait no more than 6 minutes 3 or fewer times. So for the first one here, it's a probability that x is, it says 3 or fewer, so therefore it's less than or equal to 3. Use my calculator here, get the setup correct. So menu 7, it's a distribution. I go down to cumulative distribution. X is 3. Remember, it goes 3, it includes 3. The number of trials is 10, and the probability of success is 4, and you get 0.38228. So I get probability, all on my nice calculator, not like when I was doing this, and that's to 4 sig fig. Okay. Then it says, hopefully you can read this. Let's see, can I go down further so you can read it? So there we go, hopefully you can read that. So probability of x is less than or equal to 3, use my calculator, the binomial function key on that, there we go. And B, a lot of the answer is in the setup, isn't it? That's how you answer it. More than 4, right, okay. More than 4, so it indicates that it's going to be 4 or less, isn't it? So therefore 1 minus the probability that x is less than or equal to 4. So all I have to do is go onto my calculator here, the setup again, and the beauty of this, it will retain the information that I've got there, but now x is going to be 4. And that's 0.6331, but I have to do 1 minus that. So this is a thing I often get wrong in my rushing. So I need to take 1 away from that, use my calculator here, make sure my calculator, the setup is the fix mode is correct, and that my fixing I'm doing to as many degrees of accuracy. I've just corrected it because last time I got that wrong. So it's 1 minus 0.63310325576 equals, there we go, a lot better. So that is to 4 sig fig, that equals 0.3669, again to 4 sig fig. Then the question says, assuming Claire's beliefs are correct, again another assumption, calculate values of the mean and standard deviation of the number of times she has to wait more than 6 minutes to catch a bus in a week. So what we need to remember here is that the expected value, so here this is part 2, so our expected value is NP, and that's how we do that, and our variance of the value is NPQ. Remember, Q is 1 minus P. So the mean value, the expected value, is simply going to be 10 times 0.4, and that makes sense. We're expecting a 4 times out of every 10. That's our mean value, and it wants our standard deviation. So if I work out first of all the variance, I then just have to multiply, square root that. So let's use this calculator here. So 10 times 0.4 times 0.6 equals 2.4. Okay, and that's the variance. So my standard deviation is the square root of that. Square root answer equals 1.549. So it's a 4 sig fig. Oops, dot there. Now it says, part 3, we are screaming through this. It says, during a 13-week period, the number of times per week Claire had to wait more than 6 minutes of the bus are as follows. So I now need to calculate the mean and standard deviation of this data. Well, again, this calculator does that all for you. Okay, so you just have to find the data for it, and it is just a list of data. So what I'm going to do on that one is number 6, and I'm just going to use the one variable here, and I'll put the information in. 8 equals, and then 8, 8, 9, 3, 2, 2, 7, 0, 1, 5, 2, 0, boom. 13 bits of data. Option, stats calculator. Oopsie daisy, where am I? Option 2. There you go. So here, using my calculator and option 2, I find the mean value is 3.923. So I get a mean value. It says there the sum of x is 51, so it might be helpful just to show that that's how I get that value there. And then the standard deviation, if I scroll down, I can find my standard deviation of 3.174. Now, if I had to show the workings out of my standard deviation, then I could do that as well. And that would be, if you remember how to do this, you've got the data rule here. So here, sigma x squared minus n times the mean squared. So that's x bar squared all over n minus 1. So if you did all of that on my calculator, just showing that I know what I'm doing here, I get 3.174 again to 4 sig fig. That's important that it's a 4 sig fig. State here now, with reason, whether your answers support her belief. Well, the means might be the close, because the mean here is 4 and the mean is there. So means are close, but the SD, the deviation from the mean, is hugely different. This standard deviation here is 3.2, this is 1.5. So because of that, because the standard deviations are very different between the theoretical model and the actual model, then I would say it's not appropriate. But the standard deviations are too different to be regarded as a binomial being a good model. Which is what I thought right at the beginning, isn't it, really? And that's how you do number 4.